is Adeyemi Oluwademilade Debra, the creator of Compass 7.0, and in this video, we're going to be doing correction to NECO Geography Practical 2023. As I said in my last video on calculations on longitude, I'm going to be starting a NECO correction series. If you are new to this channel, make sure to check out our other videos. I know a lot of students find map work to be one of the most challenging aspects of geography, but the moment you understand the concept, I know you'll come to love map work. And so without wasting any more time, let's get on to the video. Use the map of Lisam district to answer questions 1 to 10. The scale of the map in statement form is, so now the scale of the map we're given is 1:50,000 and it's in representative fraction, or shortened to be RF. So the question is on a map scale conversion from RF representative fraction to statement scale. And in one of our earlier videos on map scale, we discussed the three types of map scale extensively, and we also gave examples of the different conversions. I'll put the link in the description below so I can understand the topic more. Now let's get back to the question. So our answer should be in the format this in centimeters to the answer in kilometers. Remember the equation I said you should never forget when doing these conversions? 1 kilometer is equals to 100,000 centimeters. And if we were to write a scale representative fraction in a proper manner, that would be 1 centimeter ratio 50,000 centimeters. As you can see, it's already starting to look like our final answer. We just need to find the counterpart in kilometers, and it will look like this. 100,000 centimeters gives us 1 kilometer, and so 50,000 centimeters will give us x. Then we divide, so x will be equals to 50,000 over 100,000, that gives us half kilometer. And so we have our final answer as 1 centimeter to half a kilometer, which is the same as option A, 1 centimeter to 0.5 kilometers. The approximate distance of the major road is, now we can see a lot of roads or paths on the map, but we need to identify the major road, and that's a problem that is easily solved if we look at the key below. So the major road is this white and black striped road. And now to measure it, the best thing for us to use is a piece of string, white string preferably. So we can place the string at the beginning of the road and extend it till we reach the end, where we can mark it with your pen or a pencil. And after you do that, then stretch it out over the length of your ruler, and then you can measure it. And so by measuring the length of this road and placing it on our ruler, that should give us 13.8 centimeters. Now, if someone, for whatever reason, should approximate 13.8 centimeters to 14 and pick option C, forgetting that centimeters and kilometers are different units, then that person is going to be very wrong. So now, since we have 13.8 centimeters, that's the length of the road on the map, we need to convert it to ground distance. And to do that, we need to recall our map scale, 1 centimeter to half kilometers. And so to convert 13.8 centimeters to ground distance, we multiply by half a kilometer, and that will give us 16.9 kilometers, which is approximately 7 kilometers, option A. What is the approximate bearing of Kwambai from Kwesati? Please forgive my pronunciation. So as we usually do, we identify the places in question. So now let's zoom in. Here we can see Kwesati and here Kwambai. So now we place our cardinal points on the places in question, and then we draw a line connecting them. Now to place our protractor, we need to take note of the word from Kwesati. So that tells us that we're going to place our protractor on Kwesati. And then starting from the north all the way to the line, we have 310 degrees, which is close to option E, 315 degrees. Now, if someone had wrongly put their protractor on Kwambai, they would have gotten a wrong option, and unlucky for them, that answer is also part of the options given, which is option B, and that would have been very wrong. So always take note of the settlement after the word from. The feature crossed by a line x1, x2 is A. Now, if we look towards the southeastern part of the map here, we see the line x1, x2. So now they're asking us what feature this is that the line crosses. So I want you guys to pause this video and attempt this yourselves. Now, the answer to this question is option B, a hill. As you should have seen in your textbooks, the concentric contours that become smaller and higher towards the center indicates a gradual rise in elevation, which is the characteristic of a hill. Now, let me mention why other answers are wrong. Option A, cliff. A cliff is a very steep or vertical slope and usually shown on a map by contour lines that are extremely close together or even touching. Now, on the map, the contours crossed by line XY are evenly spaced and they are not tightly packed at all. So that rules out option A. Option C, Inselberg, is an isolated hill or a mountain that rises abruptly from a flat plain. On the map, the feature crossed by X1, X2 is not isolated. It's part of a wider elevated area with surrounding relief, and hence it doesn't fit the description of an Inselberg. So option D, a knoll. A knoll is a small or rounded hill. Simply, it is a low hill, and the feature crossed by X1, X2 is nearly 500 meters tall, and this suggests that it's too large to be called a knoll. Finally, option E, a ridge, which is a long, narrow, elevated landform with elongated contours. So now the contours here are circular or oval, they are not extended. And this also rules out option E. Now let's move on to the next question. The major factor that favors the location of FICU settlements is, first, let's identify the settlements. You can find it here in the southwestern part of the map. And now to identify a factor that favors its location is simple because directly beside it we see some triangles here. And if we look at our map key, we see what they mean: iron ore deposits. In case you didn't know, iron ore is a mineral that can be extracted to produce steel. So settlements like FICU often develop around mineral deposits due to mining opportunities, which provide jobs as well as economic benefits. So the major factor that favors the location of FICU settlements is the mineral deposits, option D. This was a straightforward question. As I always say, for these types of questions, don't overthink. The answer is usually right in front of you. Question 6. Rufus settlement is sited on a. So now we need to identify the settlement in question. So let's look for it. Zoom in. And over here, we see Rufus settlements. So as we've identified in the northern part of the map. So now the answer to this question is B, a pass. And if you've seen the diagram in your textbook or anywhere else, then you will know right away why option B is the answer. Now let me explain further. In the essential geography textbook, there's a contour diagram that looks exactly like this with the following labels: call or saddle and pass. A call and a pass are very similar contours. In fact, you can say that a pass is always a call, but a call is not always a pass. And the reason I say this is because a call is just simply a low point or a depression between two higher peaks, as we can see here, two higher peaks and then a call in between. But now, if a call is actively used as a transportation or a migration route, then it becomes a pass. Since we said a pass is basically a call that's used for transportation or migration routes, so passes can be used as trade routes leading to development of towns. And I'm sure in the case of this settlement in question, Rufus settlements, we have our settlement in a similar location. And the settlement also contains some iron ore minerals, to be specific, denoted by the triangles. And because of this, we can also see the creation of a road to gain access to those minerals. So now I'm sure we can easily see how option B, the pass, is our answer. Question 7. Blacksmiths are most likely to be found in. This question is also easy, as all you need to do is identify all the settlements and see if there's anything that could indicate that blacksmiths will be found in this area. So now let me highlight all the settlements in our options so let's make it easy for you. So now you should be able to see the answer, which is option D, Rufu. As we mentioned in the previous questions, the triangles around Rufu that is located on the saddle represents iron ore deposits, which we can easily see from our map key. Now, a blacksmith is a craftsman who works with iron and steel, shaping the metal into useful tools, weapons, and household items. So they use heat, hammering, and specialized tools to mold raw metal into finished products. And as we said previously, iron ore is a raw material that can further be processed into steel, which these blacksmiths use, making option D the clear choice. The pair of settlements that is not intervisible is, so if you watch the previous correction video, NECO 2022, then you'll find the explanation to a similar question. For the sake of first-time viewers, we'll quickly run through the concepts again. Intervisibility is the ability to see one point from another. The reason why a settlement will not be intervisible is due to the presence of a high contour between the settlement or the places in question. So if we look at our illustration and we take our reference from house A, what can we observe? From house A, we can see house C, and hence house A and C are intervisible, while house B cannot be seen, and so house A and B are not intervisible. So now that we understand this concept, let's go back to the question. The question is simply asking us which of the following pairs of towns cannot be seen from the other. So let's evaluate all the options one by one, starting from option A, Kwambai and Kwesati, and both of them are intervisible, and that makes option A wrong. Option B, Kwesati and Lisam, both of them are intervisible again, so that makes option B also wrong. Now, option C, Lisam and Pakia, both of them are not intervisible, and that makes option C the correct answer. As you can see that the ridge that has the pass that we discussed earlier is the reason why these settlements are not intervisible, as it prevents them from seeing each other. So now we just need to rule out the other options. Option D, Lisam and Tunga. Both of them are intervisible, and that also makes option D wrong. Then option E, Mubitoso and Tamaya. Both of them are also intervisible from each other, making option E wrong. I'm sure you may be asking, how come other options are correct? That are there some things blocking it? That is not just a direct view from the both settlements. But in other options, we can see roads and paths between the settlements, and that's not high enough from obstructing the places. Unlike option C, where we have a huge ridge between the two settlements. So it's obvious that from Lisam, the person won't be able to see Pakia, and from Pakia, the person won't be able to see Lisam. Now, question 9. What is direction of flow of River Bisola? First, let's identify the river. Then let's place our cardinal points. Now, rivers always flow from highland to lower elevations, and if we look towards the top of our map, the River Bisola seems to be originating from the ridge and flowing towards the lower plains where we have the settlements. So if I draw an arrow, it would point downwards, that is towards the south. So now all we need to do is establish if it's flowing in the southeast or southwest direction. And looking at the map, it should be clear to see that River Bisola moves slightly to the right, which is eastward. So that makes the answer D, southeastwards. The direction of flow of River Bisola is southeastwards. Question 10, which is our last objective question. Which of the following settlements is a nodal town? To answer this question, we first need to know the meaning of a nodal town. A nodal town is a central town that connects surrounding areas through transport, trades, and services. So it's basically a central point for economic, administrative, or transport activities, and also connects surrounding areas. So let's identify all our options and see which settlement best fits this description. So looking at these settlements, we can immediately rule out options A and E. The reason being that their locations both are on highlands, and so they have little to or no connection to any settlements. So there is no way they will be the central points of Lisam districts. That leaves us with B, C, and D. And from these three, I believe that the answer is clear, option D. So now let's look at the reasons why. Firstly, it has roads that connect or lead to majority of settlements on the map. And another reason is that if you look at all those letters, all those shortened form of words that surround the city and compare them with the map key, you find that Lisam settlement has two churches denoted by CH, one market denoted by MKT, one police station denoted by PS, and one court denoted by CT. And these already denote the economic, commercial, and administrative functions of the settlement. Lastly, not to mention the name of the whole map is Lisam District, indicating that it's a very important settlement. Even though that's the name of the map, don't always assume that the name of the map is going to be the nodal town. The examiners might try to trick you in a question, but in this case, we don't need to worry about that. And now let's move on to the practical geography aspect proper. Use the map of Elisha SE to answer the questions that follow. Question 1A, draw an annotated cross-section profile from point A to B on the map. Now let's look at the whole map. So now this is the whole map. But the question only asks us to draw an annotated cross profile on line AB. So we're going to focus on that, this section AB. This is a close-up of the line AB we need to make a cross profile of. In WEC 2021 correction, we also need a cross profile. So you can also watch that video after this one if you want to see more examples of cross profile. And I'll be making a video on this alone if people would like that. So now the first thing to do is to get our strip of paper and place it on line AB. And it should look like this. Now, if you aren't given a piece of paper during an exam, you can use the back of your question booklet. It doesn't really matter because you're not submitting it. You just need to make sure to mark the correct contours, features, and rivers that cross line AB. As you can see, I marked out the points A and B on the strip of paper. So now all we need to do is to indicate the features that cross the map. So you just saw how I marked all the features. In your exam, please use pencil in case of mistakes. Not even in case of mistakes, always use pencil. Whether you are very thorough with your work or not, always use pencil. Pencil is the safest bet. So as you can see, that not only contours, we're not only marking the contours that cross line AB, we also have a minor road here, a minor path, which is indicated by the dotted line, and also a river, which is indicated in blue. You obviously will not have time to be changing pens in exams. So the only reason I'm doing it here is to make a clear distinction. So in exams, you can indicate your river with an arrowhead, as I did here, using a pencil. You could also write a small R under the road so that you don't mistake it for a path when it's time to put them on your graph. Now that we've marked out all our points, another thing to be careful about when indicating the features is the placement of the paper. When marking our points, we should try as much as possible to keep the paper aligned to point A and B we marked out initially. Because if we keep moving the paper around, the features you mark will not be completely accurate, as you could make a mistake and mark out the same point twice or even skip a contour. I want you to also take notice of the way I indicated the two types of roads that cross line AB. The first one, which was plain, was a minor road, while the second one towards the end of the line is a secondary road, which is striped. And I know this because of the map key. The reason I differentiated them will be clear when it's time to draw them or when it's time to indicate them on our graph. Now, all we need to do is indicate the height of the contours that we've marked out. And for that, we need to find the contour interval. Now, if we zoom in, we can see the contour 1200, 1250, and 1300. 1200, 1250, and 1300. And with that, we can say that our contour interval is 50 feet. And the unit is feet because it's shown at the bottom of the map, contour height in feet. So for those who can't really see the numbers clearly, the difference between them is 50, from 1200 to 1250, and then 1300. So now we should be able to indicate the contour lines for all the lines marked, and it should look like this. Identifying the height for each contour line is the trickiest part, and you have to be careful when doing that. Now, if you look at the contour height, some people that are new to cross profile might find it strange the way we have some repeating values of contour lines. Like at the beginning, where we have a cluster of 1350, 1400, 1400, 1350 again. And around this river, not only do we have two 1250 contour lines, we also have two 1300 contour lines beside them. Now you must be thinking that I might have made a big mistake somewhere because since our contour interval 50 feet, and shouldn't all the contour lines either be increasing or decreasing by 50 feet, like we see at the end, close to point B? The reason is because the contours are continuous. They are not just lines that go on forever, they curve. And that is why we have some similar heights beside each other. So let's try and take the different parts along this line and understand where we have these contours to make sure you guys fully understand the concept, starting with the first part. I don't know how many people have played that game about a snake that keeps trying to eat some fruit and it keeps growing longer and the game ends if the snake bites itself or it hits the wall at the edge, and it looks kind of like this. So you can think of this pink snake as a contour line. Now let's say we have our line AB, and this pink snake will be the 1200 feet contour. If we were to mark the path that the snake crosses the line, we would have to do that in three places: 1, 2, and 3. And if we were to write the height of the contours that we marked, then all of them would obviously be 1200 because it's the same snake after all. So keep this principle about contour lines in mind as we move on. Now, this contour line is 1250. Let me make it bold for you guys to see. Now, would you believe me if I told you that this 1250 feet contour line that we see here is also the first contour that crosses our line AB at the beginning? Let me trace it out so that you can see the whole extent. And so this also makes the first contour 1250 feet. It's just like the illustration of the pink snake I gave earlier, that the same contour line also crosses the line again around here. This 1250 feet contour line crosses our line AB in three places: at the beginning, here, and here. Now we've already indicated that this line is 1250. And so that means the line below it will be 1200. That's this line here. And since it's pretty faint, let me highlight part of it. Again, the contour line before it, that's this one here, is the same 1250 that we traced out. The same one that crosses line AB at the beginning is also this one here. And then the round one beneath it will be 1300. Now let's pause for a while because some people may be confused about how we are naming the contours. So now I've recreated the area we're looking at. Forgive my drawing skills. So let's put the area side by side to make it easier to compare. So in my sketch, the darkest contour line is 1250 feet. The same one that crosses line AB at the beginning and is one we traced out earlier in pink. So while the next circle we can see is 1300. And now it should be easy to see that we have some sort of elevated or hill-like structure. Some may still ask why it's increasing and not decreasing as we move inward. Well, the only way this would have been 1200 and not 1300 is if the next contour looked like this. So we can see that this contour line here is not indicating an increase in slope, but rather a decrease from 1250 to 1200 feet as the contour continues downwards and is a continuous contour that moves downwards. So I hope we now know why it's increasing, why this our contour line that we have is increasing and not decreasing. Now let's go back to our previous image. So we can easily name the remaining contours. 1350 and 1400. And if we were to bring back the part of line AB that is visible in this picture, as well as the points we marked, now we should be able to see the reason why the contour lines are labeled as such. So now at the beginning, we have our first contour line as 1250, which we also see here. The next contour, 1300, also the same one here. The next contour line, 1350, 1400, the same thing here and here. Then beside this 1400, the next line that also crosses it is also 1400 because after all, it's the same round contour. And that's why we have two 1400 beside each other. Then the next one, the same 1350 and 1300. And after that, we have the same 1250 feet contour line that started this across profile diagram right about here. And now I'm sure we know why our contour line at the beginning looks like this. So now let's look at another cluster of features that I marked out. So now I'm sure that we can all see the darkened contour line, 1250 feet. Let me point it out to you to make it easier for you to see. So the next round small contour that we have here after 1250 will be 1300. And since it crosses line AB twice here and here, that's the reason why we have two 1300 beside each other on our cross profile that we marked. After that, we see a river between two contour lines that both have the value of 1250 feet. And surprisingly, it's the same 1250 feet contour line that started across profile. So now we've already indicated that this is the same contour line that we traced out with our pink pen earlier from here. But now we're going to follow its course again and move further. As you can see, comes down and crosses the line. Just beside it is the river I was talking about. Then it goes down, turns, and it curves, and it comes back up again to cross line AB. And between the two 1250 feet contours, we see our river. And that is what we have here. So now we can see why the cross profile looks like this. It's not just a mistake. The curving of the contour lines is similar to the snake illustration I gave earlier. But I don't want you to be only under the impression that we must always have the same or close values beside each other anytime we're doing cross profile. As we can see towards point B, we can see a steady increase in the value of our contour line, which is perfectly normal as well. As we have earlier established, this dark contour line is 1250 feet and is the same contour line that we still see here, the contour line that encloses the river. And so this makes the contour line above it 1300 feet. Now don't forget that our contour interval is 50 feet. So let me highlight the 1350 feet contour that I was talking about. So now since this is 1300 feet, then that should make the line above it right here 1350 feet. Then if we keep moving up and the contour lines keep increasing in 50s, so 1350, 1400, 1450, 1500, 1250, 1400, 1450. If we bring it out again, 1350, 1400, 1450, 1500. So here at the beginning, we can see the 1300 contour line that I marked out, and we can see how it crosses line AB in two places, here and here. And then we can see how it encloses the river between it. That's the same thing that we have here, 1300, 1300 with the river in between it. Then we have the secondary road that crosses line AB just after that, which are indicated here, the striped black and white road. And then after that, the contour lines just keep increasing from 1,350 all the way to 1,500, the same thing we can see here. And now I'm sure we've all gotten a good grasp of cross profile, but the journey is not over yet. We need to do the final thing, which is to transfer all the points to our graph and plot them. First, we have to pick a suitable scale, and I'll be using 1 centimeter to 200 feet. If you watch the WEG 2021 correction video, you will see that the question also gave us a scale to use, but our question didn't specify the scale for us to use, and so we have the freedom to choose for ourselves. 1 centimeter is half of the big box, which are representing with 200 feet, while the whole big box is 2 centimeters. So be careful when writing the values on the vertical axis. Only 1 centimeter, that's half of our big box, is what we're representing with 200 feet. So now let's mark all our points. These are all the points, and just to remind you that these points only represent the contour lines, as they are the only ones that have values that we can locate on the graph. The other features like the river, the minor roads will be added in a while. So sometimes when marking the points, it may seem a bit tricky since the distance between the paper and the point to be marked is a bit far for your eyes to trace accurately, and that is why you should use a ruler to help you mark all the points accurately. The smallest box on the paper is 40 feet, and so you can see that while marking the points like 1,250, 1,300, 1,350, and some other points, the dots are not exactly on the lines, but a little bit above or below to denote the extra 10 feet or so. Now let's connect all the dots. So our cross profile is finally coming to life. All that's left to do is to indicate all the other features apart from the contours, and the map key will help us name them properly. Another thing I want to mention is that when joining the points, they should be smooth and curved and not done with a ruler to make the cross profile look like a zigzag appearance like this. No, our cross profile shouldn't look like this. You're supposed to use like your free hand to make sure that we have the smooth curves and not a continuous zigzag. Now our cross profile is complete and it looks wonderful. All the names of the features were from the key. So for the cross profile, it may seem difficult and time wasting, but if you take your time and try to understand it, you'll find that you'll be done with your question in no time. So make sure to rewatch this part as many times as you want until you understand every aspect of cross profile. Now the cross profile is only part A of this question. In exam, don't get too lost in the cross profile and forget that there are other parts still in question 1. Now question 1b, calculate the distance in kilometers as the crow flies from Ilesha to Orita Ijeda settlements. Now, if you've been following our previous videos, the term as the crow flies shouldn't be new. In case you're hearing it from the first time, it simply means the distance in a straight line. So now let's get the part of our map that we need. Now let's identify the places Ilesha and Orita Ijeda settlements. Then we draw a straight line connecting them, and then we measure it, and this gives us 25 centimeters. So hence it's always important to take your long, preferably transparent ruler to your exams. So now that we have the distance of the map, we need to convert it to actual or ground distance. And for that, we need the map scale, which was written at the bottom of the map. Coincidentally, this is the same scale as of the map we used earlier in objective questions. So now let's convert 25 centimeters to ground distance. As we have earlier established in our when we solved the objective question 1 ratio 50 centimeter 1 ratio 50,000 centimeters is the same as 1 centimeter to 0.5 kilometers. Using this scale, we can easily convert 25 centimeters to ground distance, which gives us 12.5 kilometers. So 1 centimeter equals to 0.5 kilometers, 25 centimeters equals to y will be equals to 25 times 0.5 kilometers, giving us 12.5 kilometers. So please don't always be in a hurry. Even though you have to be fast in exams, accuracy is equally, if not more important. So the distance in kilometers as the crow flies from Ilesha to Orita Ijeda is 12.5 kilometers. Now for question 1c, what is the stream order of River Oni? Identify the direction of flow of River Oburu. Now some of you might have come across direction of flow, but the concept of stream order is new, so let me explain it first. Stream order is a method used to classify the hierarchy or size of streams and rivers based on their position in the drainage network. The most common method used to classify rivers or streams is Strahler stream order system. When using Strahler classification, the size of the streams ranges from first order stream to the largest, a 12th order stream. Now let's look at the first order stream. The first order stream is the smallest and simplest of streams. They have no tributaries at all feeding into them. Take note of that. And it's often located in the uppermost part of a drainage basin. Now for a second order stream, is formed when two first order streams meet. So I'm sure you guys are already seeing the pattern here. So that means a third order stream will be formed when two second order streams meet. So now let's illustrate this to make it easier to understand. So now let's start from the top. First order streams, as we said earlier, located at the top of the map, they have no tributaries. They're usually the smallest and the simplest of the streams. So now the first order streams combine, and that gives us two second order streams. As you can see, two first order streams combined here and under two, and now we have two second order streams. Now when these second order streams combine, we have a third order stream, and this keeps on going till we have the largest, a 12th order stream. Now in the Strahler classification, there is another thing to note. If two streams of different orders join, neither increases in order. That is, there is no change. So let's take an example. If a first order stream were to join a third order stream, then the first order stream simply ends by flowing into the third order stream. And the third order stream maintains its position in the hierarchy. Simply, it doesn't increase to a fourth order stream or become a second order stream. It remains a third order stream. The only way it can change is if it meets another third order stream and then it will combine to become a fourth order stream. So in summary, we have a first order stream plus a first order stream giving us second order stream, second order plus second order giving us third order. Or if a first order were to join with a third order, this it will still remain a third order. There will be no change at all. Now let's go back to our question. So this is a part of the map that contains the aspect that we're concerned about. Remember, the question is asking us the stream order of River Oni and the direction of flow of River Uburu. So we can see the two rivers in question here, River Oni and River Uburu. Now, at the top of the map here, we can see River Oshun. Now we can see how River Oshu flows towards the east, but as it flows, River Oshu gives off a branch that flows southward and merges with this river here, and this is what continues as River Oni. So now to find the stream order of River Oni, we need to start from the top. Looking at River Oshu, even though it's located at the top of the drainage basin, so we may think that it is going to be a first order stream. But we also said that first order streams have no tributaries flowing into them, and River Oshu doesn't follow this principle. So that means that River Oshu can be a first order stream, so it's likely going to be a second order stream. Now that we've established that River Oshu is a second order stream as well as the branch it gives off, we said that again it joins this river here. And this river that it joins is also a second order because we can see two smaller rivers joining to form it. So that means that these two small rivers that join to form it are first order streams. So two first order streams join to become a second order stream. So now we see two second order streams, one from River Oshun and one that these two first order streams just formed. And so when two first order streams unite, they form a third order stream. And this is the stream order of River Oni. I know you guys can see some other rivers that join River Oni. So I'm sure you must be wondering that how come it still remain a third order stream? Why isn't it increasing in hierarchy? So I hope you remember what I said before, that for a river to increase in hierarchy, it has to join with another river of the same order. So now let's see these rivers that are joining it and evaluate them, whether they are going to make River Oni increase or retain its hierarchy. So let's see, this river that joins River Oni here is a second order river, and that is because we can see that it is being formed by two first order rivers here. They join to form this second river that flows into River Oni. And even though we can see another smaller stream that joins it here, it doesn't change its hierarchy because this is also a first order. So this is a first order stream flowing into a second order stream and is going to retain its initial hierarchy, the second order stream. And if you look at the other rivers and you try to denote it, you can see that it's the same case for all of them. So no other third order stream joins River Oni to increase its hierarchy, and hence River Oni will remain a third order stream. So again, just to reiterate my points, all the other rivers that join River Oni are not third order streams or rivers. So you can try to look at it yourselves as well. So hence its hierarchy won't change. This confirms that River Oni is a third order river or stream. Now that we've gotten the stream order of River Oni, we need the direction of flow of River Uburu. Remember, when rivers flow, they flow from highland to lowland. So now all we need to know are the contour lines that the rivers cross to be able to determine its direction of flow. So now let's put our cardinal points. Back to the contours related to River Ogboro. Near River Ogboro's origin, we can see two contour lines that cross it. The first one, that is this contour line, and if we trace it upwards, we can see that it also corresponds to the first contour line that crosses our line AB. And if you were following from earlier in the video, then you know that the value of this contour line is 1,250 feet. While the second contour line that we can see here is 1,200 feet. And if we follow the course of the river further down, we can see that it also crosses another contour line, 1,150 feet, just below the place where River Ogboro is written. I didn't assume all these contours, rather I traced them from the top. So if we take our pointer here, we can see the 1,100 feet contour line, but it doesn't have a long course. But after that, we can see the 1,150 contour, and it can be traced down to the part I marked. So now let me highlight River Ogboro. Don't forget that the river flows from highland, where we have larger contours, to lowlands. And we can see that the contour line is decreasing as we go from 1,250, 1,200, 1,150. And so the direction of flow of River Ogboro will be northwest. River Ogboro flows upwards and slightly to the left, that is northwest, before joining River Oni, where the two rivers form a confluence. So now moving on to the last question, 1D. Describe the relief and drainage patterns of the mapped area. This question is a combined question, as you need to make sure to discuss both the relief and drainage characteristics of the map. In 2019, there was a similar question, but it was framed differently. So in this answer booklet, describe 3 relief characteristics and 3 drainage characteristics of the map. So the only thing for this question is that they were not specific numbering. That's an NECO 2023 question. It was not given, we were not given specific numbers of how many characteristics of relief and drainage patterns to write. So you can write as many as you can, but 5 each will be more than enough. So let's discuss the relief first. Now for this, you don't need to think too far, just write what you can see on the map. The first thing we can see is that the mapped area is generally a highland region, and this is obvious from the varying contours that we can see on the map. Number 2, the eastern part of the map, especially the southeast, has several closely spaced contours indicating steep slopes. So now looking at the southeastern part of our map, we can see several closely spaced contours together, and this indicates a steep slope. Now in the southwestern part of our map, right here, we have gentler slopes with wider contour spacing, indicating more lowlands. If we look at this highlighted area and compare it with this place that we marked previously, it is obvious to notice the wide spacings between the contour lines. So the wide spacing indicates a gentler slope and lowlands. The presence of V-shaped valleys indicating active river erosion. This can be seen around Ijebu, Ijesha, right around here. So you can see I've marked out some V-shaped valleys, V-shaped valleys. We can faintly see the V outline. The presence of calls and passes in the northeastern part of the map. Now, if you remember, we did an objective question on this earlier. We said that both a call and a pass are similar. A call is simply a low point or depression between two higher peaks. And if a call is actively used for transportation or migration, then it becomes a pass. And we can see them clearly in this magnified picture. Because of the dotted lines that pass through them, they are going to be passes and not calls, because these dotted lines indicate minor parts, and this minor part means that it can be used for transportation, and hence what we should have originally called a call will now be a pass. Now let's move on to the drainage characteristics. Number 1, the mapped area is well drained with a dense network of rivers and streams. Now it's obvious that this map is well drained because you can see rivers in almost every aspect of the map. That is, all those blue lines you can see that basically cross or run through the whole map. Number 2, the drainage pattern is predominantly dendritic, showing a tree-like branching system. So dendritic drainage means that it's like a tree with different branches. So from here you can see how these rivers branch out. They look like a tree giving off different branches. And this happens throughout the course of the whole map, giving out its different branches. That's why it has the dendritic pattern. Number three, many of the rivers have numerous tributaries, indicating a mature drainage network. It shows that the river system is not in its early stage, like a single straight stream, but rather it has evolved to collect water from a wide area. But in exam, you can just stop after writing many of the rivers have numerous tributaries. The rest, as you can see, was just inferred. Now, number four, rivers generally flow from highlands in the north and east towards the south and western parts of the map. This also corresponds to the direction of flow of River Guru that we got earlier from north to west. Most river valleys are V-shaped, showing signs of youthful and active erosion. So we mentioned something similar when discussing relief. When rivers are in their youthful stage, they have high energy and erode downwards into the land, and this is what carves out the V shape. Now, this may seem contradictory with what I said previously about the drainage being mature. Although the river valleys are V shaped, showing youthful vertical erosion, the drainage system itself, that is, we're talking about all the rivers as a whole now, is mature, with numerous tributaries forming a well connected and efficient network. So this means that the landscape has already had time to develop many river branches, even though the rivers still flow through the steep terrain and are actively deepening their channels. But all of these explanations are not necessary. Just focus on what you can see. The map is well drained, the drainage pattern is dendritic, rivers have numerous tributaries, the direction of flow, and V-shaped river valleys. And with that, we've come to the end of this video. I know a lot of people have been asking about the maps I use, and I'll be doing a sort of giveaway for some work and NECO maps from different years. You have to follow the instructions and answer the questions on our Instagram page, and the link will be in the description box below. I don't have a specific number of people I want to give maps to, but I'm going to leave it open for an extended period of time depending on the engagement. So if you have any topics that you want videos on, please type them out in the comment section below. Make sure to like, share, and subscribe. Thank you.